Hey Chemistry, Mrs. KJ here, going over the Unit 3 Solubility Lab. And let's go ahead and get started. You don't need to turn anything in, just answer the questions as they pop up. Lesson 3 Laboratory, Factors Affecting Solution Formation, or in other words, how do we make solutions? Well, let's stop and remind ourselves what a solution is. A solution is made when a solute dissolves in a solvent, or for example, when sugar dissolves in water. It is possible to alter the dissolution rate in the laboratory. Okay, what does dissolution mean? It means dissolve. What does rate mean? It means how fast. So dissolution rate means how fast something dissolves. And we can change different conditions or different things to make things dissolve faster, so have a higher dissolution rate, or dissolve slower and have a lower dissolution rate. Several factors affect a substance's rate or speed of dissolving, or dissolution rate. In this laboratory exercise, you will alter factors as you create solutions. You will then identify a solute based on when it precipitates out of a solution. So in other words, we're going to tell what was dissolved based on when it becomes a chunky solid again. You will also apply the concept of collision theory to understand the significance of your results. So the goal, determine the effect that particle size and temperature have on dissolution rates. Factors such as temperature and surface area can influence the rate of solution formation. Temperature and surface area can influence the rate of which a solid solute dissolves. This concept may seem easy to understand, but it is an important one for chemists who need to characterize the relationship between temperature and dissolution, and between particle size and dissolution, or dissolving, in many types of laboratory procedures. Look at the picture of salt dissolving in water. The temperature of the water and the surface area of the salt crystals influences the rate at which the salt dissolves. The knowledge that dissolution or dissolving can be explained in terms of particle collisions is called collision theory. This theory states that the particles that make up any solute or solvent are in constant motion. So the salt molecules are moving, the water molecules are moving, the water molecules bump into the salt molecules, and instead of them being in a nice square or cube, it breaks them apart into little pieces that you can't see, and then it's dissolved. When water, particles collide with solute particles, in this case salt, dissolution or dissolving is the result. This lab is about comparing the temperature and solubility. So before we do, let's talk real quickly about particle size. What is going to dissolve faster? If I have one big chunk, or if I have the same amount, but they're little tiny pieces. The little tiny pieces would dissolve first because they have more area, more surface area, more places that the water can hit at once. So if I put these little salt crystals in, the water can hit here, 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 all over, right? But if I just put in one chunk, it could only hit the outside surfaces, so it would take longer. It would take more collisions of the water molecule to break down one big chunk, versus when it's little pieces, it's like it's half the work's been done for you. It's already partially broken down. And that's what dissolving is. Just breaking it down into such little pieces, you can't see the difference just by using your eyes. Alright, this lab is about comparing the temperature and solubility. In this lab experiment, you will investigate the effect that changes in temperature have on the rate of dissolving. Then you will use data that you have collected to identify an unknown solute. A key component of identifying the unknown will be graphs that you make, commonly called solubility curves. Alright, so we have a few different things. First of all, the vocabulary word saturated. What does saturated mean? Saturated is when no more solute can be dissolved by, the solvent at set conditions. Okay, so you can't dissolve anymore unless you change something. And which one is the water? Is the water the solute or the solvent? And I always think the solvent is water in a very bad vampire accent. So the solvent is water. Write the goal of the lab or the question that you tried to answer. So what is this? What's the main idea here? And the main idea is, how does temperature affect the speed something dissolves, or the rate of dissolution, or the rate of dissolving? All right. So now we need to get some data. So let's go to our lab. And in our lab, we have a few different things going on. So we're going to do one chemical at a time, and this first chemical is KCl, or potassium chloride. And so we're going to get the water temperature of 4 different beakers, and we're going to see how much we can dissolve before it becomes saturated. And what does saturated mean again? It means that no more can dissolve. So let's go ahead and take a look. Let's get some data. So what is the temperature of beaker A? It would be 4.9. So we'll write that down. 4.9 degrees Celsius. What about beaker B? The temperature of beaker B is 30.1 degrees Celsius. And beaker C is 55.2 degrees Celsius. And now we need the temperature of beaker D, which is 70.2. So what's happening to our temperature as we go from A to B to C to D? Our temperature is going up. So if it's getting warmer, do you think the same amount will dissolve in each? Do you think that the most will dissolve when it's cold? Do you think that the most will dissolve when it's warm? All right, so let's see what we got. We're just going to do scoops. Oops. And I got to take this out so we can see it. So I'm going to stir it up. And if you notice, there was stuff at the bottom, and now it dissolved. Okay, so it dissolved. Is it saturated? No, because it all dissolved. Saturated means no more can dissolve. So, all right, let's put in another scoop. Do you see how there's some sitting at the bottom? Okay, that's what we're looking at. We're looking at that white layer at the bottom, or if it's clear like this one is. All right, so we're looking at the white layer on the bottom. I am stirring it up. And did it all dissolve? Yes, it's gone. So is it saturated? Nope, I can put some more in. All right, so now I have some at the bottom, and I'm going to stir it up and watch. And did it all dissolve? Yep. Is it saturated? No. All right, let's put in our fourth scoop. So stir it up. Did it all dissolve? Yes. Is it saturated? No. Saturated means no more can dissolve. All right, so let's put in our fifth scoop. Did it all dissolve? Yep. Is it saturated? Nope. All right, let's put in our sixth scoop. Did it all dissolve? No. Is it saturated? Yes, it is saturated. All right, so let's do scoops. Oh, it has it in grams, that's right. So each scoop equals 5 grams, and so it took until the sixth scoop, so 6 scoops times 5 grams per scoop gives me 30 grams. It became saturated. All right. So now let's do our next beaker. And we put in 1 scoop. Did it dissolve? Yes. Is it saturated? No. 2 scoops. Did it all dissolve? Yep. Is it saturated? No. All right, scoop number 3. Did it all dissolve? Yep. Is it saturated? Nope. Keep going. Scoop number 4. Did it all dissolve? Yep. Is it saturated? Nope. Scoop number 5. Did it all dissolve? Yep. Is it saturated? Nope. Scoop number 6. Did it all dissolve? Yep. Is it saturated? Nope. Scoop number 7. Did it all dissolve? Yep. Is it saturated? Nope. Scoop number 8. Did it all dissolve? Nope. Yes, sorry, yes it did. It did. Is it saturated? Yes. So that took 8 scoops to saturate this one. All right, so 8 scoops. Each scoop is 5 grams, means I had how many total grams? 40. So when my temperature goes up, can I dissolve more or less? I can dissolve more. And the reason is that when things are warmer, the molecules are moving faster. The faster they move, the more they collide with each other. The more collisions, the faster something's going to dissolve. All right, so that tells me that this one has a temperature of 55. Is it going to dissolve more than 40 grams, exactly 40, or less than 40? It should do more than 40, right? Because it's getting warmer, there's more collisions, so it's going to dissolve faster. So that tells me we can go a little bit faster on this one. That tells me I can start out with 8 scoops because I know it's going to dissolve because it's even warmer. So 1, 2, 3, 4, 5, 6, 7, 8. So if I'm right and I stir this up, what's going to happen to all this KCl that's in there? Did it all dissolve? Yes. Is it saturated? No. All right, so I can put in scoop number 9. Did it all dissolve? Nope. So is it saturated? Yes, it's saturated. So that took 9 scoops. And if it took 9 scoops and each scoop is 5 grams, how many grams total? 45 before it became saturated. Now, beaker D is the hottest. What does that tell you about how much can dissolve? Well, it's going to be more than 45 because it's warmer, because there are more collisions, and so it happens faster. And more can dissolve. So 1, 2, 3, 4, 5, 6,